Welcome back, mathematicians. In this video, we are going to look at the area of a sector of a circle, linear speed, and angular speed. Let's start with the area. The area A of a sector of a circle of radius r, formed by a central angle of theta, radians, is the area equals 1/2 times the radius squared times theta, the angle in radians. Central angle in terms of radians. So the key here is that theta needs to be in terms of radians. If at any time it's in terms of degrees, to use this formula, you will have to convert it over to radians. So to give you a visual of what's happening, if I have a circle and I draw a central angle in that circle, what I need in order to calculate the area of this sector of the circle is the radius being the distance from the center of the circle to where the ray intersects the circle, and I need the central angle theta, and theta would be in terms of radians. So I have to find, in my first problem, I'm going to find the area of the sector of a circle of radius 5 feet formed by an angle of 40 degrees, and I'm going to round the solution or answer to the nearest two decimal places. Let's start by converting 40 degrees to radians. I'm going to do that by multiplying by pi over 180 degrees, which will give me, if I do the product, will give me 40 pi over 180 radians. And then I need to reduce, and when I reduce, I get 2 pi over 9 radians. I am now prepared to use the formula because I have the angle in terms of radians. The formula is equal to, or the formula is, area is equal to 1/2 times the radius, which in this case is 5, quantity squared, times the angle in terms of radians, so that's 2 pi over 9. Now, I do encourage you to use your pi button on your calculator, not 3.14, but what you get, rounded to two decimal places, should be 8.73. Now, the units are going to be feet squared. Squared because it's area, and feet because that is the units, that's the unit of the radius. Let's now look at linear speed and angular speed. Before I read this, I just want to relate this back to something you are probably very familiar with. The formula distance is equal to rate times time. So in this case, instead of a distance being a straight line distance, we are going to look at the distance around a circle. And because it's the distance around a circle, we are going to look at the arc length. So if we start right here on our arc or our circle, and then we end right here, we would want to know that arc length, which we know is represented by the letter or variable s. We then are going to look at, instead of using the r for rate, we're going to instead call it v for velocity. And then finally, we still use t as a unit of time. We are now going to solve this for v, and so we get v is equal to s, the arc length, over a unit of time. And so that is the formula that we're going to use to find linear speed. Now I'll read it. So it says, suppose that an object moves around a circle of radius r at a constant speed. If s is the distance traveled in time t around the circle, then the linear speed v of the object is defined by v is equal to s over t. Now let's go to angular speed. Instead of speed being measured as a distance over a unit of time, this time it's going to be measured over radians, or an angle over a unit of time. So theta is an angle in radians over a unit of time, which can be represented as, hours, minutes, seconds, etc. So the angular speed omega, that is omega, by the way, I'm not very good at writing it, so it looks more like a W when I write it, of an object is the angle theta measured in radians swept out divided by the elapsed time t. That is, omega is equal to theta over t. We are now going to use that information to solve this problem, where we have an object traveling around a circle with a radius of 5 centimeters. If in 20 seconds, a central angle of 1/3 radian is swept out, what is the angular speed of the object and what is the linear speed of the object? Let's start with the angular speed because, believe it or not, we're given the information to directly find angular speed without a lot of extra work. So angular speed, which is omega, is equal to theta, that central angle in terms of radians, divided by t, the unit of time. In this case, the central angle in terms of radians is 1/3 divided by t, which is 20 seconds. So when I take this and simplify it, what I end up getting is 1/60th of a radian per 1 second. Okay, so 1/60th of a radian per 1 second is my speed. Now, if I wanted to calculate this in terms of a decimal, rounded to, let's say, 2 decimal places, what I would end up getting is 0.02 radians per second. Okay, so perfect, in the perfect form, it's going to be 1/60th of a radian per second, and decimal would be 0.02 radians per second. Now, in order to find the linear speed, I actually need to find the arc length. Okay, so the arc length, S, is equal to theta times R. In this case, theta, again, is 1/3, and R is actually 5 centimeters. So I find the product and I get 5/3, and we are dealing with centimeters, so centimeters. So that is my arc length. Now I'm going to use the linear speed formula, which is V is equal to 5/3, which is the arc length, over unit of time, which is 20 seconds. When I simplify this ratio, what I end up getting is 1/12 of a centimeter per second. Now, if I go ahead and calculate the decimal, rounded to 2 decimal places, what I get is 0.08 centimeters per second. So again, linear speed is going to be a distance per unit of time. So it's 5/3 centimeters for 20 seconds. I go ahead and divide those and I get 1/12 of a centimeter per second, and then I can divide that again 1/12 in order to get 0.08 centimeters per second. Please read the directions very carefully and understand if the directions want you to give the exact answer, which would be 1/12 centimeter per second or 1/60th radian per second, or if they're okay with a decimal rounded to the nearest 1 or 2 or 3 decimal places. All right, guys, good luck.